after the Manhattan Project. The third focus is our tools. So you may have used MuckRock requests, or you may have used one of our other platforms such as Document Cloud. We're growing that umbrella daily. In the meeting notes for today, as I dropped in the chat, at the end, we do have a call to action. We are asking for proposals for folks who have journalism tools that would like to join the MuckRock umbrella under a grant that we were just awarded under the Knight Foundation. So if you are an original author of a journalism tool that you would like to see fall under our umbrella and get supported, please do check out that application. Today's presentation, you can follow along anything that we cover in the slides. You can follow along without installing any dependencies or anything like that in a GitHub code space. So if you have a GitHub account, all you have to do is log in and go to the code space into the repository, and then you can click on code and create a code space on that repository, which allows you to pull in all the different tools that we'll be kind of covering today. They'll come pre-installed in that code space, so you don't have to do any of the install commands. I do provide the install commands if you want to run things locally as well. One note is that if you're using the virtual environment, you will have to precede commands with the words uv run. So if you want to run a script, you do like uv run Python 3 and then the script name. Or if you want to get into the Python interactive shell, which we might be doing a little bit today, you do uv run Python 3, which gets you into the interactive shell. This is where all the libraries and plugins are installed as well. So a brief agenda for today's meeting. We're already a little bit over time, but that's all right. The first aspect is we'll be covering a library called LLM and how you might be able to use it. It's a library written by Simon Willison. It's great. It allows you to use models without worrying about individual API calls. You just set up your API keys and it handles all the API calls for you. And you can pipe different things into an LLM model of your choice. We'll then have a demo and discussion about LLM Document Cloud, which is a plugin for the LLM library that we introduced in the previous section. It allows you to feed Document Cloud documents into your favorite large language models for better document analysis. Then we'll dive into a little bit briefly into the Python Document Cloud library, which is the Python wrapper for the Document Cloud API. LLM Document Cloud uses several, a lot of code from that library. Then we'll shift our focus away from a little bit of document analysis into public records requests. So I'll be demoing a little script. It's really crude right now, but it's kind of a choose your own adventure. It's called FOIA Suggester. It allows you to put in a topic that is of interest to you, and then it looks up previous successful requests on MuckRock requests, types in that language from those requests into an LLM of your choice, and then generates a unique new request that it proposes that you might want to file. And then you can file that request if you choose to do so. After that, we'll go over a brief overview of the Python MuckRock library. That is the Python wrapper for the MuckRock API. That is what powers FOIA Suggester. And then we'll leave some room at the end we'll try to leave some room at the end for questions. We might hang over a little bit on time, and if you have time, stay over for questions. So without further ado, what is LLM? Again, LLM is a Python library and command line tool written by Simon Willison. It allows you to run prompts across a variety of models without worrying about the underlying API calls or implementation. It allows you to just set up your keys, and then you can run prompts at will. So how to set up LLM? LLM is already set up on the code space, but if you are looking for quick reference material on how to do this on your own machine, this slide would help inform you of that. So you'd have to install LLM. You have to install whatever plugin that you want to use. So if you're looking at using Google's Gemini model, you'd have to install that plugin, or if you're using the LLM Document Cloud plugin, you would have to install that plugin. And then you want to set your API keys for the large language model that you're looking to reference. There are also local models through plugins like Olama if you have a GPU that is capable of using that. You can run models locally on your machine as well through LLM. Some quick reference material as well. If you kind of want to dive into LLM and experimenting with it on your own, you can list what models are currently available on your machine in your local environment by running the command LLM models. So in the code space, you would run UV run LLM models. You can install a plugin with LLM install. By default, LLM runs prompts through GPT, through OpenAI, but you can specify a different model that you want to use based on a plugin that you've installed by using the -m command line argument. Something really useful, especially if you don't want to worry too much about syntax or you want to remember something for the future, is you can use fragments to pass along more information with your prompt. So if you just run like LLM -m and then specify your model and then specify a prompt, you can't input any other information into that context for the into the large language model. But you can pass in things like files, or as you'll see in a moment here, you can pass in documents or pages from a document using the Document Cloud plugin with the -f parameter. You can also set up an alias for that other context that you want to provide for the AI using what are called aliases. And then by default, the default behavior of LLM is that you're sending a prompt and you're getting one response. If you did want to chat, for example, with a document, you could use LLM chat and then pass in the document that you wanted to reference. That would create a chat interface between you and the model where you can ask it questions and things of that nature. Chris, I will hand it off to you from this point forward. But
Great.
I can control the slides if you'd like, or if you want to switch to screen share for you.
I'll talk about the tool for a minute and then I'll switch over. Hi everybody. So I've been a fan of LLM for a while and I've been working on Document Cloud for even longer. And one of the things that I've been wanting to figure out how to do since Simon started working on LLM is pull in Document Cloud documents into context. And two things have made that much easier in the last few months. One is that the models themselves have gotten better with longer context, which means that you can put a whole giant PDF into your context. And then the second thing is Simon added a feature to the LLM tool called fragments, which lets you store pieces of context that you're going to refer to over and over again in your local database. So for a little bit of how LLM works under the hood is that every prompt and response you do gets logged to a local SQLite database. This came out of Simon's work with Dataset, and it's really useful for analyzing how different models work with similar prompts or with the same prompts. So you can run the same prompt against 5 different models, see what you get back, and then look at it in the database and say, what is giving me the most useful response, or what's hallucinating, or vice versa. But one of the things that Simon ran into is that if you're constantly pulling the same large chunk of context into, or large file or something into context, you just fill up your database with the same repeated stuff. And so fragments sort of solve that problem. But part of the plugin system for that let you write new fragment loaders. And so really what LLM Document Cloud is doing is adding a fragment loader for Document Cloud. Under the hood, it's using the Document Cloud Python client, which Sunyan's going to show later. And it actually opens up a lot. So it can use your Document Cloud credentials. Right now, that means putting in a username and password in your environment. I'm not going to do that for this one because I don't want to give you guys access to my account. Um, on a screen share, but for public documents, it's actually really easy. You don't need any credentials except for what you're going to use for your LLMs.
I'm gonna
Um,
stop my screen share and hop over to you, Chris.
yeah,
Okay. All
let's do it.
right, go ahead.
All right, cool. So you all should be seeing my terminal here. I've been playing with this a bit just in the background, just trying some things out. I'm going to clear my screen here. I'm going to pull over this document. So this is make it a little bigger so you can see it. This is a White House staff list. I forgot how I came across this, to be honest. I think somebody posted on News Nerdery and I a link to it and I grabbed it and said this needs to be in document cloud. And so now it is. So it's a public document. I'm going to put it in the chat. So if anybody wants to just look at it, you can. Except I can't find the chat now. I'm screen sharing. Oh, there we go. Too many screens, too many controls. Yeah, so this is our document. Um, it's a table, it's one of the many tables that you'll find in PDFs, and that we all constantly complain about. And I think the most frequent question asked uh, on News Nerdery is how do I extract this table from this PDF? Or maybe that's an iCard listserv. I don't know. There are lots of ways to do it. I'm going to show you how to do it with LLM and Document Cloud. So I have um, set my API keys. I'm going to use, actually, before I do that, so Sunyan mentioned that LLM is sort of a bridge between lots of different models. It normalizes how you use it. So these are all the models that I have available, just that from plugins I've installed, OpenAI, Claude, and Gemini. My default is GPT-4o Mini, which is not the newest one, but it's pretty good. It's actually the one that people still like because it's the one that doesn't try to think too hard. Um, so it's probably a good one for this. So I'm going to um, do this. Uh, so what I'm going to do is I'm going to use LLM. This dash F is fragment. So that just says load a fragment, whatever this thing is that you're going to load. Pull it off the internet, pull it off your file system. There's a lot of fragment loaders, but it also will not pull it again if it hasn't changed. So I pulled this a minute ago. It hasn't changed since then. And then this last bit is the prompt. And so what this will do is it'll basically make a prompt that is this document, actually the extracted text. So it'll feed all of this text into the model, and then it'll tack on um, my prompt at the end. Um, if I wanted to add my prompt first, I would do it as a system prompt. Um, but this is fine. So I'm just going to run this and it'll go. And we're off to the races. One thing I will say is that I don't trust LLMs any farther than I can throw them. So you should check this. Uh, Lots of people are running evaluations on different LLMs and seeing how well they could do common tasks together. I think Derek Willis has a project to extract, while this is running, I'm just going to say this, to extract backers of campaign emails. And he runs it against every LLM he can find. And you get some are really good at it and some make up all kinds of stuff. Um, so you want to double check everything here. This is 9 pages worth of stuff, so it's going to go for a while. But I'm going to scroll up just so you can see something here. So one thing that it does is it gives me this sort of chirpy response of certainly, here you go. it's real. The LLM is really excited to help you out, for better and worse. Um, and then it wraps everything in these code blocks. While this is running, I'm going to show you a cool tool for dealing with this. So if you are expecting something like that to come back, you can add this -x or extract option, and it'll pull that out, um, and it will just return that. So if you wanted to just pipe this to a file, which is probably more useful than piping it to your terminal, you could use that. It does still log the entire thing to the database.
One thing that I wanted to note here is I did some preliminary tests on handwritten documents as well.
Hmm.
And if you load the image, so one thing about the LLM document cloud library that's cool is you can load an image. You can pipe the image to the LLM of your choice, and it does a pretty decent job of. I was like pretty surprised with how well GPT-4o Mini was at like getting data in tabular format from that image. Um,
Yeah, it's for all of the hand-wringing about AI and what it means, and I don't have answers on what it means. Um, they're very impressive tools, and like this is real easy. It would actually be faster if I wasn't also running Zoom and a million other things. I'm gonna actually open a new tab while this is happening. Actually, I'm just gonna abort that. Um, I did it up here and got the whole thing. So you can keep going with that. I'm gonna do another thing just to try this out. I'm just gonna ask a question of it. Who's the highest paid person on this list? That's interesting. So that gave me a different answer than last time. So last time I ran this, it said Dan Scavino. So um, this is the non-determinative nature of LLMs.
maybe the model that you're using as well.
Yeah, I'm gonna see. What I have. And I'm gonna try a different. I'll try Claude Force on it. Different answer. Um,
How it goes.
yeah, that's interesting.
Mhm.
Um, oh, hmm.
Chris,
Yeah,
I don't mean to interrupt. Do you think we could pipe over to continue?
yeah. All right. I'm gonna get distracted by doing this because I run these little experiments all the time and it's fun. Um,
If you could start the presentation, that would probably be helpful.
yeah.
Oh, I guess eh, there's no way for me to show the screen with the commands and also, that's all right.
I'll hand it back to you. Anyway, that's all, and we'll come back to it at the end.
Okay. Let me restart my code space. Share. Hopefully folks can still see my screen. I'll get over to. Okay, so underlying the LLM document cloud plugin, which allows you to pipe documents into LLM, is the use of the Document Cloud API. So if you wanted to load, if you look at the library details, you can load like pages, images from a document, entire documents, text from a document, various different levels. We use API calls to be able to reach those assets. And so we use the Document Cloud API to do that. Document Cloud API allows you to do a lot of different things, search within a document and across a set of documents, similar to how the UI works when you log into Document Cloud. It allows you to upload documents from a file or URL, create and modify or delete projects, notes, and also document data, which are key value pairs that you can store on a document that contains extra information, things that you could use an LLM to extract from a document and then tag. It allows you to apply optical character recognition to documents to improve the quality of text that's extracted from the docs. And then it allows you to also build and call pre-existing add-ons, which are little reusable Python scripts that allow you to further process documents in a schedulable or repeatable fashion. So what is Python Document Cloud? Python Document Cloud is the Python library or wrapper around the Document Cloud API. It provides you a client, which you can access the different endpoints really easily. Full documentation is also available. You can install it using pip. You can install it in your code space as well, although it comes pre-installed using UV run pip install Python Document Cloud. So let's get a little bit more familiar with Python Document Cloud. You need to authenticate to use the client. You can pass like an empty, like Chris mentioned, you can do client equals Document Cloud and then open close parentheses. However, this will limit you. Some of the filters won't work for some of the endpoints, as well as you aren't able to access your own documents. So if you're looking to work with private documents or documents within your organization, you're not able to access that without authenticating. You authenticate with your username and password. If you think about publishing a script that you've used in the past, we do encourage you to use environment variables in your local system and then referencing them within Python using os.environ. So searching documents is really straightforward, but it can confuse some. There are officially two different methods in the Python client, as well as the generic API that allow you to search across documents, but they're very different. The first one is documents.search. That uses Solar Search. When you use the Document Cloud website and you search for documents, like let's say you're looking for documents that contain the word Robert Mueller on documentcloud.org, that is using Solar Search. It has indexed the full text, the title and description of each document, the key value pairs of the documents. That is what allows you to use the search interface. This API call, it supports full search. It's more performant. It also returns to you a count of how many objects match your search. List is different. It uses Postgres, uses database operations, and it does not support full text. It also doesn't return a count of objects returned for performance reasons. It only returns to you a cursor paginated response, which means that you have to iterate through different pages. So you have to, if you want to see, you get 25 results, and then if you want to see the next page, you have to do .next or .previous to look through the full set. That being said, most of the time they'll just be using search. If I wanted to search for all the documents on Document Cloud that had the word FBI, I would do documents.search and then parens FBI. It supports a lot of different parameters. There's a full search documentation that outlines how searching on Document Cloud actually works, and that is applicable to the API as well. That being said, if you wanted to do some more advanced search, for example, if I wanted to search only certain documents in a project that I have on Document Cloud, I can specify a project ID, and I do project ID. Additionally, you can combine search operators. So I can filter by which documents in a project have a specific keyword. as well as documents that are only in a specific project. So for this one, I'm going to actually go ahead and Python first. Let's not. All right, we'll skip that then. Looks like for some reason my local environment got borked on that code space. Sorry about that. So let's go back. If I wanted to search, by default, the text search, when you do like on the previous page FBI, it does a search across the full text of documents, the description, and the title. If I wanted to limit it to one section, like let's say documents that only have it in the title, I would specify title, or I could do doc_text for the full text of the document. So it excludes, for example, documents that have the word Western in the title, but it has it in the full text somewhere. In the reverse, in this example here, if I wanted to search only documents that had the word Western in the title and was in this project, this is how I would do it. And this is a wildcard character, which allows you to be more broad about your search. So you can capture a document that has the title that has the word Western somewhere in the title. It's not just documents that are in that specific at the beginning of the title, for example, or just Western in general. Similarly, if I wanted to find documents by their creation date or their upload date, I can do that. That is one search operator I can use. It's the created at. And then this is kind of the format that you would use for that. It's basically, it gives a range. I only want to care about the documents from the last month until today. So it's now minus 1 month. That's 1 month ago exactly, to today's date. And I ran this yesterday. It was about 33,000 documents were uploaded in the last month on Document Cloud. So working with documents, you can retrieve a single document. Either, let's say you did a search. Recent docs is like you did a search like this, where you had recent docs. It returns to a list response. You can reference it either using the index, or if you want to retrieve a single document that you have uploaded somewhere or found somewhere, you can pass in the document's ID as an integer and retrieve it using the get documents.get. A single document has many fields and methods available, and you can see the full document list with all the operations that you can do, as well as all the fields and methods available. But some of these are, I think, the most important when we're talking about working with LLMs. And some of these actually do appear in the code for LLM Document Cloud, which is open source. So you can, for example, get the full text of a document. You can get the raw PDF of a document. This is if, for example, the full text embedded in the PDF is poor. Like, let's say it's a handwritten or image-based PDF. You want the LLM to actually get the PDF in context, not just the OCR text that was provided. You can load the PDF. Similarly, if I wanted to only like get a table from a single page or something like that, I can use large image. One other thing is data. Data is a dictionary for each document that provides additional data. So, for example, you can add tags or key value pairs to a document. So let's say I'm running some kind of task on my document set, and then I want to store those attributes back to the document in some kind of saved format. I could save them in the data dictionary. So, for example, if I wanted to categorize my documents by when they were published, originally, not when I uploaded them to Document Cloud, I could pull the year using an LLM and then tag it with year and then the value of that when it was uploaded, like 2019 or something like that. Uploading documents, it's limited to only verified journalists. So if you don't currently have a verified account or not a member of a verified org, you're not able to run this endpoint, but you're still able to run the other endpoints. You can upload either a raw PDF that's stored locally on your machine or point to a URL to a raw PDF that's uploaded somewhere on the web. You just do documents.upload. You'd specify the location of the PDF and then a title. And additionally, if you are writing things that work with LLMs, something that might be of interest to you is the ability to upload documents in bulk. There are some handlers built into the Python client. Upload directory, which allows you to upload by default all the PDFs in a local directory that you specify. And then upload URLs, which gives, you can provide a list of URLs. Let's say you're scraping a site and you wanted to upload them to Document Cloud for future reference. You can use upload URLs, provide the URLs where the PDFs are located, and they would upload them. That being said, if you are trying to upload a really large set of documents, for example, 10,000, 100,000 documents, we do encourage you to use our homebrewed batch upload script, which creates a database and keeps track of which uploads were successful. It also has some performance improvements on our side so we don't get hit with performance degradation. So what are add-ons? I mentioned them briefly a little bit earlier. They're reusable scripts that we use kind of like the Python client and an add-on class. And additionally, these scripts are hosted on a GitHub repo. And when you run them on the Document Cloud site, they kick off a GitHub Actions run. So it runs that script, sends that data back to the user, and then it performs some action on Document Cloud itself. It allows you to do some kind of automated task in a repeatable and schedulable fashion. There are some LLMs that are helpful. There are some add-ons that are helpful for document analysis that already exist. There are OCR add-ons such as Textract and Azure Document Intelligence. There are some table extraction add-ons, as well as some LLM add-ons as well. Some examples are Klaxon, which allows you to monitor web pages for changes, and it gets you notifications either through email or Slack. And the other one is Azure, which allows you to run a premium OCR option on your documents to get better text recognition from things that are handwritten or image-based or scanned. I am going to skip just covering really quickly the GPT-4o add-on. It is on the site. You can try it. But for time's sake, we are going to have to move forward a little quicker because I want to demo FOIA Suggester. So I'm going to hop over into the code space. Let's see. Okay, let me set my credentials. Reset when so let me reset quickly my credentials in code space. Sorry about the technical difficulties. There we go. Okay, let me share screen again. Share. Okay. So I ran the command using uvrun Python 3-m and then FOIA Suggester. It's loaded in the code space automatically. You can run this as well. The first thing that the script does is it runs LLM models to show me which models I have loaded in my current environment. So I want to pick a model. Now I'm wondering if the keys for code for the Gemini is also loaded, maybe not. It allows you to set up a topic that I'm interested in researching. So for this case, I'll do, actually, let's do facial recognition. It allows me to narrow my search for requests on MuckRock requests to a specific state or federal level, the USA. I'm just going to say no for this example. And then it searches the MuckRock request database for requests that are related to facial recognition. It finds successful requests, so it filters the requests by their status as being done. And then it will pipe this, the request language of each request into a context for the Gemini model and generate a new request for me. So hopefully this works. If not, I have to set the keys. It did work. Great. So this is kind of the response that I get from the LLM from Gemini. It's a newly generated public records request based on successful requests in the past that are hosted on MuckRock requests. I can see here it has some facial recognition. It has like different categories of documents that is pulled from different requests, an inventory, acquisition of financial records, some policies and procedures, performance audits. These are things that I'm familiar with because I've filed public records requests about facial recognition in the past, and these are kind of documents that are of interest to me. One thing I'll note is the date, I think, is like from January 2017. This might be too broad for someone who's trying to file a public records request. That's more recent, but that's fine. The script does offer me to actually create the request on MuckRock requests and file it. If it's of interest to me, I'm going to say yes. It allows me to put an agency that I want to actually file the request with. So I'm going to do Chicago Police. It sends me a response with which agency that I want to actually file it with. So I'm going to select Chicago Police Department, which is number 1. And then this is really important. You need to have request credits. So it could be under your individual user or an organization that you're a part of. I'm going to file this under MuckRock. So I'm going to select the number 1. And then it asked me for a title for the request. So I'm just going to label this test request because this is just a test one, and I'll delete this afterward. But it files the request. So if I go to this link, if I copy it over and go to this link, why did that not work? Oh. There we go. So you can see this is a draft request at the moment, but you can see the auto-generated language. I specifically told the LLM not to like cite any laws or anything like that. So that will be excluded, but this is generated from the template for the request. And you can see it's filed it to the Chicago Police Department. So I'm actually gonna go ahead and delete this because I don't actually plan on filing this request at the time. But yeah, that's the FOIA suggester tool that I spun up kind of in a day, just based off of an idea. To run this, you do need to have your MuckRock username and password in the code space. So that's what I had to do when I turned my screen share off momentarily. So how does FOIA suggester work? We can dive into that a little bit. Let me full screen this. Okay. The FOIA suggester uses the MuckRock requests API underneath the hood, which allows you to search requests filed on MuckRock with some filters, retrieve communications and files from a request. That's one thing that the FOIA suggester doesn't do right now, but it could be an implementation in the future. Maybe it pulls requests, the files from a specific request to see what generated documents came about. It allows you to query our jurisdiction and agency databases to figure out where you might want to file the request. And then it allows you to also file public records requests. Of course, that requires some credits on the account, but it does allow you to do that in a more automated fashion. What is Python MuckRock? Python MuckRock is the Python wrapper or Python client similar to Python Document Cloud for the Document Cloud API. It exists for the MuckRock API. You can install it using pip. You can use it in the code space. It comes automatically installed. Similar to Document Cloud, Python Document Cloud, it authenticates in the same way. You create a client and then you access the endpoints via the client. So for example, I wanted to do a search of requests people have submitted in the past. I could do requests.list and press a search parameter. This will give me all of the requests that has the word recipe in it, somewhere in the title or in the actual request language. If I wanted to filter by my completed requests, which is something that this script does in the source code, I can use the status parameter with the search. So I can search by the status done. I could be more inclusive with this. If I wanted to include like partially completed requests, I could do include the status partial. Once you retrieve a request, it has different attributes. The title of the request, of course, the status of the request, whether or not it's been completed or withdrawn or things like that. And then requested docs, which is the request language of the request minus the template. So it doesn't include the cited law or anything like that. That's just in the FOIA template. It's just the language that the user input when they filed the request originally. This is what gets piped into the FOIA suggester tool to do. You pipe that into the LLM as context. When you file a request, you need to figure out where a request goes. Part of that means that you need to figure out what agency it belongs to, and ultimately you might want to look at what jurisdiction that agency belongs to differentiate between two agencies with the same name. That's what the jurisdictions endpoint is for. So if I wanted to filter, for example, all of the jurisdictions in the database that are state level, I can pass in the level parameter into jurisdictions.list. If I wanted to filter jurisdictions by their name, I could pass the name, which is a partial search. So it'll do anything that starts with, like I don't have to do Kentucky. Literally, I can do Ken, and it should pull in Kentucky for me. Similarly, I covered request search in the previous slide. You can filter requests by what jurisdiction they were filed in. So if I wanted to see all of the requests that mention the word surveillance in the Massachusetts jurisdiction, this is how I would be able to do that. Similar functionality is in the FOIA suggester script. And then agencies, again, this is where you actually file the request. So each agency has a jurisdiction that they belong to. It can be a state, a local jurisdiction, or for federal agencies, it can be just the USA. So if I wanted to, for example, search for all the agencies that have the name Illinois State in it, I can do agencies.list and pass in the name parameter and do a partial search, which you can see here returns several different agencies that exist in the database. Similarly, I can filter agencies by what jurisdiction they belong to. So if I wanted to get all the agencies that belong to the Massachusetts jurisdiction that have the word police in it, I could do this one, and it will return to me different police departments within Massachusetts that are in the database as well. Again, one example that you might want to, when you run into filing a request using Python MuckRock, is you want to figure out which Springfield Police Department is the correct one to file to. In this case, you would want to do look at the Springfield Police Department agency, look at what its jurisdiction is. If it's a local jurisdiction, you might have to do one more request to see what parent is that local jurisdiction. And in this case, the agency with the jurisdiction ID of 258, it belongs to Massachusetts. So that agency belongs to Springfield Police Department in Massachusetts, not the one in Illinois. That is something that you might have to do differentiation. Another thing when filing a request is as in FOIA Suggester, you get prompted with which org you want to build a request to. You need to know which organization you want to bill to. You can only specify an organization that you're actually a part of. If you don't, you'll get an error message. So you do need to figure out what organizations you're a part of, what their IDs are, and then figure out which one you want to actually bill in order to file the request. And then filing the request, you need 4 different fields to successfully file the request. You need a title for it, which you get prompted in the FOIA Suggester script. You need requested docs, which is a string. This is what gets generated by FOIA Suggester. That's already provided for you. You don't do any additional things with that. But if you wanted to file your own request, you do need to specify requested strings. You need agencies, which is a list of agency IDs that you file the request to. So let's say I wanted to file it to the Chicago Police Department. It has a specific ID in the agency database. I need to find that and specify that when I'm filing the request. Similarly, for organization, you need to specify your organization ID that you want to bill for the request. And this is the structure of the data. And then this is how to actually create the request using the Python MuckRock library. So if we wanted to quickly break down how the FOIA request suggester works, you need to allow us to search the MuckRock database for requests of the subject matter we're interested in, filter those by whether or not they're done or partially completed, feed the language or requested docs of each request into the LLM. And then if we like the request, we can pick an agency and file the request. That's kind of at the deepest, the logic that's behind the FOIA Suggester library. We're at the end of the hour. There are a couple more slides in this one that you can review on your own time, which is basically breaking down how the FOIA Suggester might work. It is also open source, so you can take a look at the code for that. And we're kind of planning more development in that way. But for now, since we're at the top of or at the end of the hour, I do want to open up the floor to any questions, and I will open to the Building with MuckRock meeting event to see if there's any questions posted in the document. So if you have any questions, please feel free to unmute. Otherwise, I will look at the document to see if anybody's posted any questions during this presentation.
I see no questions.
I also see no questions. Chris, if nobody has any questions, we can also open this to a time of like what kind of things people would like to see in the LLM library.
Yeah, I'm happy to do that. If there isn't, or if there aren't any immediate questions, or if you'll just need a minute to think about it. I know we threw a lot at you today, because we have a lot of cool stuff and y'all should use it. But one thing I've been thinking about with this LLM document cloud library is that right now it really only does one thing, which is it makes it easy to get documents that are on Document Cloud into your LLM context so you can use them with the model of your choice. And that enables a lot, but it's not everything we could do. So Sunyan showed off the Python document cloud library, which does a whole host of things, basically everything our API can do. And I would like to think about how to pull more of those capabilities into LLM. The big one that I have thought about and haven't quite figured out how is search. So you could say, give me all the documents in this project, and put it in context. I don't know if that'll work. I don't know if models have big enough context for them. And then the other thing I'm trying to figure out is embeddings, because that enables stuff like similarity searches and semantic search. But I sort of want to open it up to people and say, like, what is interesting to you about mixing Document Cloud with LLMs, and what would you like that library to do, if anything? And feel free to just unmute yourself and tell me things.
I had an idea. I do think that like entity extraction is something that we've wanted to do in the past and didn't have an elegant way of doing so, especially with
Yeah.
like limited OCR capabilities in the past. I think that this opens up a lot of opportunity to be able to interact with entities and create entities, um, even if it's on a local database level. I think actually that's somewhat preferred for some use cases
Yeah.
for journalists as well.
Yeah. Actually, I'd be willing to try it. If you have, do you have a good document? I'm looking through mine that would work for pulling out entities. Like I have that White House list, but the entities are just the list of names, so
Yeah.
it's not very interesting.
Let me see if I've got anything off the top of my head.
If anybody has one that you want me to try, let me know because I can at least.
Oh, I have some. Hold on.
Oh,
Let's see some like FBI documents that I got as a
yeah,
public records
that sounds
request. That might
fun.
be interesting.
Yeah, and while Sunyan's pulling this up, if anybody else just has a document you want me to try and run a query against, just to see what happens, we'll do it. All right. I'm gonna pull up my terminal. I'm gonna share my screen. We're just all gonna see how this goes in the spirit of fooling around and finding out. Um, should I do this raw? This is a handwritten document, so or I should
Scam.
put
Yeah.
yeah, it does have text extracted, so yeah, actually this is pretty good. Ooh.
I think it should work.
Yeah, let's try it
I think
out
I've
and
OCR'd it before too. So
yeah, I think yeah, that's did it. Okay. What do you want to try to prompt for this? I'm actually gonna do this. Just do it like this. What do we think?
that's pretty cool.
Yeah.
I did want to show off. I can show one document that I've run. Table extraction that's like handwritten as well.
Oh
Uh,
yeah.
do you allow me to use screen share?
Oh yeah.
Great. Let me show off this one as well, which I thought was kind of impressive. This is a document for a project that we worked with CCIJ related to the Nigerian elections in 2023 and analyzing polling data. They got a lot of these like photographed polling tables, basically like how the ballots were counted in each individual locality. And a lot of it's handwritten and really blurry, or it's a scan of a handwritten document and so on. And in a previous article that I've written about table extraction, a lot of both the OCR tools as well as LLMs really struggled to extract the table in a really coherent way for me. But I was surprised with how well some of the LLMs work now. It's been 2 years since that has been the case. So let's go ahead and run it and see how it works. So I think it's doing like a pretty decent job of getting the data that we want. Of course, I didn't specify like a format for CSV or anything, but it was able to pull out I can see here like uh 6. So it missed a digit here, added hallucinated votes here. This is worse off than it did previously, but it still is able to pull in a lot of the data from the top table. Um, in other experiments, it was like almost 100% accurate here. But it was interesting enough that like for a table extraction, it worked pretty decently for a handwritten document. It did, of course, as mentioned, like the hallucinations do still occur. So it's always important to verify these as well. And that was part of the approach that CCIJ actually had, is they used MuckRock's assignment tool and distributed these images to volunteers. And so each volunteer was responsible for reviewing like 20 to 30 of these polling data tables, and was able to verify whether the extracted text matched the actual image, and if it didn't, offer corrections. So that was part of their approach that I thought was really interesting. Just wanted to show that off as well. Anyone have any questions? Otherwise, I think we are at time. We're over time for the session, and we'll let you go. See, you see anything in this sheet? Nothing. No questions. Okay.
No. Thank you all for coming.
Yeah. Thank you, everyone.
These are fun tools. Go out there, play with them. Tell us what you find. Hit us up on the MuckRock Slack or in News Nerdery. We'd love to talk about it more.
Bye, everyone.